Landscape Overview. This short video will provide an overview of information regarding landscape files used in WFDSS fire behavior analysis. It will cover how to create a landscape, the components of a landscape, and how to view the landscape layers within WFDSS. Other short videos within this topic include landscape critique, creating and utilizing barriers and masks, and editing a landscape. An analysis landscape is often referred to as an LCP for short. A landscape, or LCP, in WFDSS is comprised of 8 spatial layers representing topography, which includes slope, elevation, and aspect, fire behavior fuel models, and canopy characteristics, including canopy cover, canopy base height, stand height, and canopy bulk density. These 8 layers make up an LCP. However, before we can view the layers in WFDSS, first a landscape must be created. To begin this demonstration, I am viewing the information screen of an analysis. I am showing a near-term simulation, but the process for creating a landscape is the same for Basic, Short-Term, and FS Pro. Creating a landscape is a 2-step process. First, the users must draw the extent of the desired landscape from the Analysis Map screen. To do this, I will click the Analysis Map option. Once the screen loads, you will utilize the Draw Rectangular Extent button, which looks like a dice, to draw a box to include the area you want for your analysis landscape. You may notice that a green rectangular box is already drawn on the screen. This is a default extent and can be overwritten. Simply click the dice button and then click and drag a box with your mouse and release the mouse when it is the size you want. If you mess up, just click and drag a new box until it is the desired shape you want. Now select Save. After selecting Save, the green rectangle represents the extent of your landscape. When drawing the extent, consider how large you think your projection might be. The extent should contain your ignition point or polygon and should encompass the projected fire growth for the duration of your simulation. If it's not big enough, the projection could be cut off. But if it's too large, you may waste time by forcing calculations on areas where the fire doesn't end up burning. The larger the extent, the longer the analysis would require for processing. There is a limit to the size of the landscape a user can create. You will receive an error message when creating a landscape if it exceeds the allowable size in WFDSS. Drawing the extent is just the first step to create a landscape. Now you have to do the second step, which actually creates the landscape. In WFDSS, the landscape layers can be viewed once the landscape is created by selecting the View Landscape button. If View Landscape is grayed out, as it is here, and not selectable, a landscape has not yet been created. From the Menu tab, select Landscape to open the landscape screen. There are a few settings to review on this screen before selecting the Create LCP File button. First, the extent box you drew is broken out by bounding latitude and longitude here at the top. Instead of drawing a box in the Analysis Map screen, users can also manually enter latitude and longitude coordinates here to define the extent if desired. You should verify the cell size resolution of your landscape. The smallest possible is 30 by 30 meters, as that is the landfire cell resolution. 30 meters is the default setting for Basic, Short-Term, and Near-Term fire behavior, and 90 meters for FS Pro. However, users should assess this value. The smaller the cell size, the longer the simulation will take to run. The larger the cell size, the quicker the simulation will run. Increasing the cell size, for example, to 60, 90, 120, or higher, simplifies the landscape even further and homogenizes the landscape layers. In fuels and topography, where a landscape is very heterogeneous, increasing the cell size may result in a loss of needed detail. But on a relatively homogeneous landscape, it may not have a noticeable effect on the output. Users will need to determine the cell size for each analysis. If in doubt, make it larger, and if your analysis finishes quickly, you can repeat the analysis and lower the cell resolution. Users must also select which data source to use. As a general rule, unless you have a specific reason to utilize an older data set, you should use the newest available, as it will contain more up-to-date information on fire scars and other disturbances and include current calibration efforts. For more information on the differences in the Landfire datasets, visit the Landfire website at www.landfire.gov. Finally, users can select to use the 40 fuel model system or the 13 fuel model system. Keep in mind that utilizing the 40 fuel model system likely provides for greater granularity and adjustments within a single fuel model type. If you make any changes to the landscape settings, select Save. Once all the settings have been reviewed and saved if they were adjusted, create the landscape by selecting the Create LCP File button. You will initially notice a green message at the top of the screen indicating your request is in progress. If you have a red error message, your landscape extent may be too big or have no data, for example, if it were in an ocean. It will take a few moments to a few minutes for the landscape file to be created. The larger the landscape and the smaller the cell resolution, the longer it will take. The landscape screen does not refresh automatically, so in order to determine if your landscape is ready, you can re-click the landscape page to reload it. When your landscape has been created, you will receive a message indicating that LCP was generated at the top. Additionally, the View Landscape option, which was initially grayed out, will now be selectable. Now that a landscape has been created, you can view the individual 8 layers of the landscape. To do this, select View Landscape. Let's now review each of the 8 layers, starting with elevation. To view a layer, select the radio button to the left of the layer name. To view the legend for the layer, select the color palette to the right of the layer name. The elevation layer, described in meters or feet, provides the elevation above sea level. To change the default unit of the legend, in this example meters, select the Switch To option at the bottom to switch to feet, in this case if desired. The slope layer describes the slope of the ground in degrees. The aspect layer describes the aspect of the ground in 8 categories: north, northeast, east, southeast, south, southwest, west, and northwest. The fuel model layer describes the designated fuels for the area and can be represented by the standard 40 fuel model system created by Scott and Bergen or the Anderson 13 fuel model system. The stand height layer, described in meters or feet, represents the height of the average value for the stand or area. The values are used to determine wind reduction and ember production during spotting. It should represent the dominant or codominant stand heights. Canopy base height, measured in meters or feet, represents the height of the canopy base above the ground. The layer is used in surface fire intensity and foliar moisture content to determine crown fire transition. Canopy bulk density refers to the mass of available crown fuels within a stand. It is used to determine the initiation and spread characteristics of crown fires across a landscape. It is measured in either kilograms per meters cubed or pounds per foot cubed. And finally, canopy cover, provided in percent, describes the average percent canopy cover of a tree canopy in a stand. In fire modeling, canopy cover provides information about shading and factors into dead fuel moisture calculations. It also contributes to determining wind reduction factors. Another way to view the landscape is to select the Eye tool and then click on a location in the landscape. The left-hand menu pane will populate with the values of each layer for the particular cell you clicked on. To review, in this video, we discussed how to create a landscape, how to view the layers of a landscape, and the components of the 8 layers within a landscape.